Here we're going to see how the pre-stack time migration routine, PSTM, and the standalone SPECS work together. PSTM takes as input uncorrected, unmigrated gathers, and outputs uncorrected, migrated gathers. Then SPECS takes over and makes the time corrections and stacks the data. So in other words, PSTM takes care of the space part and SPECS of the time part of the whole migration process. Here's a PSTM flow based on the one in help. It reads a line of CDP gathers from the installed hotline directory, and then calls PSTM to output migrated gathers, and then it sections the unmigrated migrated gathers and writes them in SegY format for SPECS. Incidentally, the curly brackets mean insert this text file here. It's a file of velocities. So let's see what we get. We'll put these two SegY files into SPECS. First the uncorrected one. We have to OK the parameters every time that SPECS gets a file it's not seen before. We'll import the velocity file, that one in the curly brackets, from the flow. So some of the functions are beyond the CDP limits, but for the rest, SPECS creates spectrums and shows the functions. Let's look at an uncorrected gather. And pick a mute. Not sure that one's needed, but anyway. And we'll look at a corrected gather, and we'll paste the mute so that it applies both pre and post dynamics. So let's see what the stack looks like. Now we'll process the migrated gathers. So it's back to HotShot's Run tab. Now when we processed the unmigrated file a moment ago, SPECS wrote a text file of mutes and velocities. And we'll use those same functions here. So let's see what we get. And we can compare the unmigrated and the migrated stacks. Now we can save these stacks as segwire files and process them in HotShot. The better to compare them. Here's a flow that reads the unmigrated segwire file that we just saved, balances it, and sections it in grayscale. And we can do the same with the migrated file. And here are the two bitmaps. And I'll flip between them. And that's it for PSTM and SPECS.